So in this video, we are going to solve this question I have on the screen here, which says that an AC supply of 230 volts is applied to a half-wave rectifier circuit through a transformer of 10 ratio 5:1. Assume the diode is an ideal diode, and then the load resistance is given to be 300 ohms. So first of all, we should find the DC output voltage, secondly the peak inverse voltage, and then C, the maximum and then average values of power delivered to the load. Okay, so we're going to start with the A. So the A says that what we should find the DC output voltage, okay, which is the average voltage. So the formula for the average voltage is that's V average is given to be the maximum voltage over pi. That's for a half-wave rectifier. Okay, so the average voltage given as the maximum voltage over pi. Okay, so before you can find the average, you need this maximum voltage here. Okay, you need know this maximum voltage here. So how are you going to find this maximum voltage here? You can find this maximum voltage using the formula V RMS. Okay, V RMS equals Vm over root 2. Vm over the square root of 2. So you can use this formula to find for the maximum voltage here. Okay, so let's go ahead. So now you see that the transformer has a primary side and then the secondary side. So before you can get this VRMS, you must find the voltage at the secondary side, and that voltage will be the VRMS value here. Okay, so the voltage at the secondary side will be the VRMS value here. So how are you going to find that? So first, we want to find this secondary voltage, which is the VRMS here. We can use the formula the voltage on the secondary side divided by the voltage on the primary side equals the number of turns on the secondary side. Okay, the number of turns on the secondary side over the number of turns on the primary side. So you can use this formula to find the VRMS value here. Okay, so let's do that. So we don't know Vs, so that's Vs over Vp. So the voltage on the primary side is given to be 230. So that's 230. So this equals number of turns on the secondary side in this case, which is 1, over number of turns on the primary side, which is 5. So 1 over 5. Okay, so when we do this, we will get Vs voltage on secondary side to be equal to 230 divided by what? 5. 230 divided by 5. Let's see what that will give us. So that's 230 divided by 5. So that gives me 46 volts. That gives me a value of what? 46 volts. Okay, so that's the voltage on the secondary side, and that's our VRMS value that we have here. Okay, so now that you know this value, you can go and then solve for the maximum voltage here. Okay, so that's VRMS equals Vmax over square root of 2. Okay, so now I want to find Vmax. So Vmax, that's the maximum voltage, will be equal to VRMS times the square root of 2 times the square root of what? 2. So you know VRMS will be 46, so that will be 46 times the square root of 2 times the square root of 2. So let's see what that will give us. So that gives me a value of 65.05. So that would be 65.1 volts. So that would be the maximum voltage. Okay, so that's the maximum voltage. So you got Vm to be 65.1 volts. Okay, so now that you know the maximum voltage, you can now come and find the average. You can now come and find the average value. Okay, so let's see. So the average was given as Vmax over pi. So you now got Vmax to be 65.1. So that would be equal to 65.1 over pi. Okay, let's see what you get for that. 65.1 over pi. And then that gave me a value of 20.7. That's 20.7 volts. So that's the average value, and that's the same as what the DC output voltage. So that was for the A. Okay, so now for the B, you've been asked to find the peak inverse voltage of the diode. Okay, you've been asked to find the peak inverse voltage of the diode. And the peak inverse voltage is the same as the maximum voltage that the diode in the rectifier can break. Okay, it is the same as what the maximum voltage that a diode in a rectifier can what? It can block rather. Okay, so you see that the diode allows voltage or current to flow in one direction. Okay, so when it is reversed, the maximum voltage that the diode can block is what is known as what? The peak inverse voltage, and that will be the same as what? The maximum voltage. Okay, that will be the same as what? The maximum voltage. This is because when you have, let's say you have a wave here, it goes to the maximum value, it will come down to the negative maximum value. So it will go up to the maximum value, come down to the negative maximum value. Okay, so if this side is 65.1, this side will also be what? Negative 65.1. Okay, and the one down here will be the peak inverse voltage. Okay, so in this case the peak inverse voltage is the same as what? The 65.1 that we have here. So PIV will be equal to 65.1 volts. Okay, so the next thing you have to find is the maximum and the average values of power. Okay, that's the maximum and the average values of power. So first of all, to find the maximum power, that's P mass. Okay, we can use the formula P equals V squared over R to find the values of what? Power. So to find the maximum power, we are going to use the maximum voltage here. Okay, we are going to use the maximum voltage flowing through the load. So that will be Vm squared over what? The RL, which is the load resistance. Okay, so Vm is 65.1, so that will be 65.1 squared. Okay, divided by the load resistance, which is given to be 300 ohms. So divided by what? 300. Okay, so let's see what this will give us. So that's 65.1 squared divided by 300. So that gave me a value of 14.126. That's 14.127. Okay, watts. So this will be the maximum power here. Okay, so for us to find the average power to we can use the average DC value voltage that we got. Okay, you can use the average DC voltage that we got to find for the average power. So let's look at that one also. So the average power delivered to the load. Okay, that's P average. P average. Okay, the average power delivered to the load will be the average voltage. Okay, which will be V average squared. The average voltage squared divided by what? The load resistance, which is RL. But in this case, you got the average voltage to be 20.7, so that will be 20.7 squared. 20.7 squared over the load resistance, which is what? 300 ohms. So let's see what that will give us. So that give us a value of what? 1.428. So let me make that 1.43. So that give us a value of 1.43. Let me write this here. So that will be equal to 1.43 watts. 1.43 watts. So that'll be all for this question.